Hi everybody, I'm Monica Alsten from Energiforsk and very welcome to this webinar on industrial Internet of Things in nuclear applications. We have a really exciting afternoon or maybe morning for those of you who are from America. We will start with presenting a study that we have done within Energiforsk on industrial Internet of Things in nuclear. And then we have Professor Paul Smith, who will delve into the security applications of IIoT. And we have a break, and then we have some information from the Nordic plants about their activities, and then EDF, followed by a break, and then we turn to the US with GE activities in industrial Internet of Things, and also information from Ted Keeger at BMS Corporation, who has experience from several different plants in the US. But before we start with the program, I would just like to very briefly present what Energiforsk is. It's an organization that facilitates and communicates R&D through collaborative actions. We bring together people from energy industry, authorities, suppliers, universities, consultants, etc. We form different R&D programs and carry out R&D projects. The company is owned by the Trading and Transmission Organizations for Electricity, Heat and Gas, and it's a non-profit distributing company. We are active in the entire field of energy, nuclear, hydro, distribution, energy systems, etc. And everything that we do is defined from needs in the industry. Everything from a very hands-on need in a power plant to perhaps a need to map some future thing that we see that will happen. It's very different kinds of projects, everything from verified to PhD students. And we do all this in close collaboration with financiers. And if you want more information about Energiforsk, you're most welcome to visit our web. If we look into what we're doing within nuclear, then we are only working with the different supporting systems and structures in nuclear. For example, concrete, instrumentation and control, vibrations, polymers, grid and plant interaction, and RFPV improvement. And today we are here thanks to the digitalization program. And briefly about that program, our vision is really to try to reduce the maintenance and operation costs, increase availability, and make nuclear an attractive industry, especially for young people that I think expect their future job to be digital. And the scope of this program is that we do some feasibility and mapping projects. We also do strategic monitoring and knowledge transfer, for example, looking into what international plants are doing or what other industries are doing that we could perhaps transfer to the Nordic nuclear power plant context. And we are also sort of a hub for discussion for the Nordic nuclear power plant experts. So in almost every meeting that we have some sort of internal workshop where we have discussions on the theme. And the program is run by a steering group with plant experts from the Swedish and the Finnish nuclear power plants. And the activities are defined by the steering group. So they have the ideas, and then we discuss the foreign projects, and then we procure these projects. That's what we are focusing on right now. We are just about to start a new project with a mapping on digital worker, like what kind of tools and systems can you get to support the worker on site. And we also have an ongoing procurement for a study on suitable artificial intelligence solutions for nuclear power plants. And this is a quite broad project, for example, on how to manage, analyze, and digitize all the drawings, but also to see if we can somehow support the persons at the plant with some sort of AI solutions to sort of sort out what is expected and what is unexpected to support in this jungle of information that they are subject to. We've also finalized a number of studies. One is the feasibility on IIoT in nuclear applications that Arto will present in just a few minutes. We also did a study on robotics and drones in nuclear applications. And this spring, we had a webinar on monitoring and diagnostic centers. And about a year ago, we also had a webinar on metal additive manufacturing. And about almost 2 years ago, we did a fantastic field trip to the UK to get inspiration from the UK researchers and companies. This is basically what we are doing in the digitalization in nuclear program. Before we start with the program, I would like to introduce Arto Laikari, who is my sort of co-moderator that will guide you through the day together with me. Arto has helped me out with putting together the program. Arto, you want to say hi?
Hello, good afternoon also on my behalf, and thank you, Monica, for the presentation. Do you want to have some house rules? Okay, they have been already rolling there, so...
I just wanted to introduce you before we sort of go through the structure of the day, that we have this main session where we have all the presentations, and then in the breaks, you are free to choose if you want to actually have a break, or if you want to sessions with the speakers that have just had their presentations before the break. So for that, we have a separate Teams channel, and when you got the links to the day, you got both the link to the main session and to this discussion session. So here is the program for the discussion session. So the first one is at 1:40 to 1:55 CET, and then you will meet with Arto and Paul. And then the second one is at 3:05, where you will meet with Andreas Björklund from Ringhals, Thomas Nyström from Fortum, and Energiforsk from EDF. And then the final one is just after we finalize sort of the webinar, and that is with our US participants, Nathan B. Asquith and Abhinav Saxena from GE Power and Chad Keegan from AMS Corporation. So you just were thrown into the webinar, just some information house rules, that we will publish the majority of the slides and videos, providing that we have the permission from the speaker. And when that is published, I will send you an email with a link. And in this main session, please keep the microphone muted and camera switched off. And when the speaker is about to finalize, it's supposed to be like 5 minutes for short clarifying questions. And if you want to ask that, just raise your hand or write in the chat that you would like to ask a question. And then either Arto or I will call upon you. And then you're welcome to unmute, turn on your camera, and please present yourself, just name an organization before you ask your question so that we know who is asking the question. And then, as I said, we have this discussion forum during the breaks and just after the webinar. And in the discussion forum, you're really encouraged to have the camera and microphone on and be very active in the discussion. So, do you have anything to add?
Thank you. That was a very comprehensive summary of the day which will follow here.
So should we simply dive into your presentation of the study that we have done in the Energiforsk digitalization in nuclear program?
Yep, we can start. So in a way, it's kind of an introduction to the day also and the content what we have today. Yeah, so thank you, Monica. So I will then start sharing my screen here and then just say if you don't see it, and then still clicking it to the presentation mode. So hopefully it's now visible with the presentation mode there for you.
Yes, go ahead, Arto.
Thank you. So, like I said, good afternoon also on my behalf. And then my name is Arto Laikari, and I work as a senior scientist at the VTT Technical Research Center of Finland. Like I said, this is an introduction for the day's theme. We have some dedicated presentations of this topic then following during the day. And then here I will go quickly through the our document or this report that we have then together with the Energiforsk then created, as it contains about 90 pages. The report, we don't go very detailed here, but hopefully we will encourage you to take a time and further explore the report. As a background and introduction for this document, digitalization is one of the mainstream driving themes across industries and society. We see the digitalization everywhere in our daily life and probably not always even think what is hidden under the surface. As the Nordic nuclear power plants, like Monica said, they are in a way supported and supporting. So it's the two-way part here for the program. Then for the NPPs, they have been designed and constructed before the digitalization age. So there is the interest to then adopt the IoT adoption or take them into the use, but then there is also some reluctance for several reasons. Because there is the old legacy devices are probably not compatible with the new systems there, and then there is the fear of then interference and other possible new problems coming there. Our report is then publicly available from the Energiforsk pages, so you can then find it there, and then you will see the link also in the presentation here. As it's a public report, we have to balance a bit with the confidentiality, IPRs, and the openness, because we would like to tell you as much as possible. But on the other hand, there is then the restrictions that we are not able to do it. But hopefully, I hope there is enough information that you can already get from here, because we have then tried to cover several aspects. The main content of the report is then shown here. So we have 4 main sections here. And then I will now briefly dig into each of the 4 sections and then present a bit what we have been discussing here about those. So in the first section, we present some of the key technologies which belong to the industrial Internet of Things. So the IIoT, and then we start, basically there are then the 4 areas which are the kind of a key concepts which are then involved in this umbrella. And then at the end, we also mention some few words about IoT forecasts, then how the predictions are then ongoing. Okay, like always with these kind of new technologies, it's this exponential growth then forecasted then for almost all of these areas. And then on the right side, you can see the Industrial Internet Consortium's Industrial Internet Reference Architecture, which outlines the landscape, and you see that there are a lot of topics to be covered here. So it's not just few sensors there, and then you are then recording, but it's then a very big concept that you have to take into account when you want to dig into this one. As a first sub-part for this IoT technology background, they are not the, let's say, comprehensive introductions of the technology, but giving the idea what is behind here. So the wireless technologies, they are an important part in the IoT environments, although IoT solutions can contain and often contain also wired parts there. The wireless technologies are presented more detailed in an earlier Energiforsk report, Wireless in Nuclear Feasibility Study, which you see the link below on the screen at the moment. And then we have still then taken some, let's say, summary parts to make this document then independent, so that you don't have to switch and jump between different documents. Although the wireless has been considered as a kind of a no-go in the Nordic plants because of these old legacy systems, and then the, let's say, the fear of then the interference, but still in the Nordic NPPs, there's also wireless applications already in use in several places there. Okay, not in the safety critical sections, but in the supporting areas. Today we will also hear more about the wireless and the IoT solutions and the status from Ringhals and Lovisa. So, and also in my presentation, I have few lines then coming also a bit later. And like in the beginning of November this year, there was also a press release from the Railers Finland announcing that in the Fennovoima Hanhikivi nuclear plant, which is at the planning phase at the moment, and then some supporting construction has already started there. It was mentioned that they are then planning to start using the network Virve 2.0 for this kind of an authority network that is then giving the wireless coverage then in the area there. And this Virve 2.0 services are operating in the 4G and the 5G networks. Basically, it's supporting all. It should be also supporting the Virve 1.0, which is then the earlier Tetra-based network. Another let's say a building block for the IoT systems is the data management. IoT creates a lot of data which needs to be processed and interpreted, because otherwise these masses of data wouldn't be useful for the humans. And then in this section, we describe briefly the concepts of the cloud and edge computing, bring out that there is several big data analytic platforms which are connected also to the IoT systems, a few listed here. In the summary part, we are then mentioning even few more. And when talking about the big data, artificial intelligence and deep learning are also the concepts which are coming up. And like you saw in Monica's presentation, there is another report, also a project ongoing with artificial intelligence. Cybersecurity. In nuclear, all the operations is a safety critical sector. So connectivity, accessibility, and new features of the IoT solutions. On one hand, they are bringing new options, and then possibilities to implement things, but they also bring new risks and threats, which make the cybersecurity as one of the important cornerstones for these systems. There is a vast group of malicious actors who are then actively then trying having different agendas for their cyber attacks, cyber sabotage, and espionage campaigns in their mind. And like we have seen, many of these groups are well financed and resourced, and sometimes even quite big players behind there. So there is then care has to be taken that we are not opening the gates for that kind of actions there. So they have to be then taken into account already in the beginning of the planning phase of the IoT systems. The next presentations we will hear from Paul then more detailed. So I'm not digging. There's several pages of the cybersecurity issues in the document, but then I save the floor for then Paul, and then you can also visit our document then later there. IoT platforms, that's in a way, that's the kind of a system that is then maintaining and then offering the serving of this concept to you. And then without an IoT platform, the challenges of building an IoT applications, they are quite significant, because developing the application logic, user interface, and the database, and developing data analytics, that creates a lot of effort and time. And there is already existing several systems that do these services. Several platforms exist, and then also service providers for them. And in the conclusion section, we have discussed a bit more about the platforms and how to choose, or then at least what to take into account when you start choosing them. And then we have to understand what each provider offers, and then what is required when we are evaluating these IoT platforms, because there are then many offerings, but you have to take then into account what you would like to then get out from those. So in a way, there is a bit this chicken and egg problem, that you should know what you are then buying. Otherwise, you might be sold something that it's not the complete best feasibility for your purposes. And then the selection of the underlying platform can be also a critical decision for an IoT-based service developer. Then what is then, because that will in a way kind of lock the direction where you are then going, because changing it later, that might be a huge task. So in a way, like a new project then starting. For the IoT forecasts, many companies and then institutions are making forecasts about the IIoT technology evolution and expansion, both technology and as well as market-wise. Unfortunately, most of these research reports are often subject to a chart, so we can't then openly refer or then copy the things there, but all of them forecast and then the increasing amount of ILS and IoT adoption and usage. So that is a kind of a main message which bring out that can be freely said. In the second section, we discuss about the IoT applications in nuclear. So this section has then four subcategories. So we are talking a bit about the regulatory requirements and restrictions, some words about the standardizations and links to the standards which are existing, tell about a bit about the IoT applications in the Nordic NPPs, and then also outline some applications in the international field. The regulatory requirements and restrictions in here, this section we discuss then bring out then the IAEA safety standards, which are the basis for the formulating national regulations. There is also then the OECD, NEA, and the Western Europe Nuclear Regulators Associations are the forums where the local authorities and regulators are interacting actively. And then in the Nordics, then like many of you know, it's then the STUK in Finland and SSM in Sweden, which are then applying these into the local use and then controlling that things are going like they should be. In the standardization field, there are a lot of technologies involved, both the nuclear field and the ICT field. So there is the IAEA, EPRI, IEEE, ISO, ETSI, etc. So a lot of standardization bodies which are working. I'm not going to list or then go them through here, but you can have a look then from our document that which one exists. Most likely it's not everything that exists, but it gives you a clue how that there is a lot of things to be then followed there. And because it's a regulated industry, then you have to then follow the accepted rules and guidelines then. For the IoT in the Nordics, the IoT and the wireless usage is still quite modest in the Nordic NPPs because of the earlier mentioned reasons. One main driver for the new technology adoption in the Nordic NPPs could be the modernization of the old NPPs in the long-term operation, so-called LTO programs, because there is the need to renew the things and then keep the systems working. And the longer the time is running from the building time, then the harder it is to find then the replacement components for some of the devices. And then, as an example from the Nordic nuclear field, the nuclear waste organizations POSIVA and SKB are using modern technologies for their nuclear repository site testing projects, which the plants can also follow and get some ideas, and then also experiments which are then in the neighborhood they're happening. And then one of the big challenges, which I already mentioned earlier, was this, that then as the report is then a public, open one, but then many of the information is classified or at least restricted. So making them available here through our document, it's a bit a challenge, or then have to balance with that one. But some of the general examples have been collected into the report. You can visit it to have a bit a better look for that, but then these include some local temporary measurements which have been implemented, like wireless vibration monitoring. There is the safeguard surveillance technologies for the seals and cameras which are in use. Already quite long time ago, then the Tetra network-based SDS messages using the fire alarm delivery has been in use. Short-range RFID identifications are in use, and then some perimeter radiation control systems. And like mentioned, we will hear from the Ringhals and Loviisa plants today more about these. Next, we have then the IoT applications in the international NPPs. It contains a non-comprehensive list of examples of various IoT projects and pilots within the international NPPs with some short descriptions of those ones. And then these include both projects, pilot projects and research approaches. Here, partly we have the same challenge that many of the information is classified or restricted, but then as the world is big, we have quite many, several open examples, which include like the equipment monitoring for valves, pumps, motors, leaks, vibration, and temperature, for instance. And then there's various radiation monitoring systems, some even with drones, and wireless applications in nuclear decommissioning and robotics in the NPPs. And then IoT and data platforms have been also mentioned in some of the projects which are in use. And then there are even some blockchain pilots and proposals both for the IoT device support, but also for nuclear material tracking. And then we will hear more about the international playground then from the GE, Hitachi, EDF, and the AMS Corp today. In the third section, we are then briefly mentioning some examples from the IoT applications in the other industries. This section contains brief examples like from the electric power and energy systems, environment, health and safety, maintenance, which is one, let's say, good area, which could be this predictive maintenance projects and that kind of thing. So if you don't even have to go to the safety critical areas, but there's a lot of other functionalities that could be surveyed and then with these maintenance programs. And then we have collected just as a list, the kind of from the Nordic telecom operators, because they are most likely already some kind of partners with the NPPs here, and they could be then also the service providers, at least for some parts of the future IoT solutions. Next, and the fourth and the final summary and final considerations, we are then going through a bit kind of a what are the ideas how to proceed, and then what are the kind of a guidance or then the help giving them to continue and start the project. Unfortunately, one single correct way to successfully adopt the IoT does not exist. In a way, it's a bit seeking, they seek for the big change in the NPPs like treasure hunt. When things go well, a big reward is waiting, but there are many traps and obstacles on the way to the treasure. Like said, the LTO programs of the NPPs can create the need for the IoT adoption, as the replacement of the old IHC technologies will most likely turn to be more and more difficult in the future. For the guidelines, and then for the IoT usage, we have collected some ideas here and then where to start. We have presented like that it consists of many technological sectors, and these bring the new opportunities but also new threats. As a kind of a cloud environment, we have then listed here what are then the key components that you should then plan to be taken into use there. And then the main gaps to fill are the integrating the IoT solutions into the existing business workflows, because the plants are already operating and things are already ongoing there. Then the question is about the managing of the new data, how to process and then use it there. And then for sure, to even start the system and the planning is to identify the use cases and the applications to be taken into use. It's advised to keep the big picture in mind, even with small experiments, because businesses tend to focus too narrowly when thinking about how to use the IoT. But on the other hand, then sometimes it might be that a small isolated experiment is needed for the gate opener, that you can then in a way start the change of the mind that, okay, that this is the direction where we should go. For the business case, in the discussions with the NPP representatives, it has been often said that the business cases are needed to support the project creation. Otherwise, the project just to start for an IoT sake is not enough there. The business case and the strategy planning should be done parallel in an iterative way. So don't try to eat the cake immediately, but chop it into the smaller pieces. And then the missing infrastructure, that like the missing wireless infra or something like that, can hinder or slow the IoT project. So there is a bit this that you have to start building the blocks there. And on the right side, we have listed some potential starting points for the NPP business case. That could be then the ideas that where then this process and the wheel starts rolling. For the strategy planning, as the NPPs are up and running, processes are already defined and working. Changes to the original business process and IT strategies need to be carefully evaluated so that we are not breaking them. And the IoT adoption can impact to the work processes and require to the changes to them. And then often there is then the danger that there comes this change resistance, that then why to break the things that are already working. And in some sources, it's said that the implementing greater number of the IoT use cases often correlates to financial success. And one important issue is also the service model for the IoT. How much own effort can be invested in that? So is it the infrastructure as a service that you are then operating quite a lot of yourself? Is it the, let's say, middle of the road, so the platform as a service that you have more functionality provided with the service provider? Or then is it so that then it's the software as a service that then it's then external service provider, which is then mostly then maintaining the whole system for you? Then the planning of the IoT system, technology and service providers involved in the design and the implementation process will offer guidelines and tools to help the planning, but the buyer should also self be aware about the possibilities and the pitfalls, because the providers, they are selling the concept which is familiar to them. So you have to be careful that it's then fulfilling your needs there. And there exists a lot of offerings from for the products and devices and services, like the IBM Watson, Microsoft Azure, the GE, that I guess we will hear some words also today, Snyder's EcoStructure, Honeywell Sentience, Telecom Operator IoT, Amazon Web, etc., etc. And then we have listed also some toolkits and guidebooks at the end of the document, so that which can be helped as a starting point when you are then start learning and then working with this in this field. The good thing in this that there is a lot of information available for, but that is on the other hand, that's the drawback, that or the bad thing, that there is so much of information that it's then tricky first to start then selecting the parts where you then start digging in there. But basically, thank you. I tried to then run quite quickly my presentation. So my presentation slides will be then available for you then. So in case you want to go back to them, so you are free to do it. And then now the floor is open for a few questions if you have already in mind, and then there will come the discussion session then after these couple of presentations. So thank you.
Links to the report is also pasted in the chat in the meeting, in case anyone is interested. And while all of you are thinking about questions to Arto, I have a question for you, Arto. This business case. I mean, I do understand that, of course, you need to have a business case in order to get funding for a project, but there are other drivers for IoT projects also. Could you elaborate on that? I mean, you have listed some like improved security, improved safety, etc. So could you elaborate a little bit more about other drivers than just simple financial?
I guess the financial thing is one of the big things there. Then let's say it's partly it's falling back to these LTO programs, that because of the harder to get the replacements and replacing the equipment which are then getting outdated or hard to maintain there. That can be one of the things which is both related to the cost savings, because the new technology will be probably or most likely providing more functionality. It will be cheaper to acquire there. For sure, there is then the adoption or the change needed for the systems there. But then on the other hand, that could be then the easy way to start getting the things in there. And then this, because I guess then when the plant is working and there is no need to start replacing the devices there, then it's a bit hard to say that you start saving money if you then buy new equipment and throw away the old ones. So it's really this edge that then there is the need for these changes or repairs, which are then probably triggering the first parts which are coming there. And I have seen that during these discussions that there are already some pilots that has been already implemented. So in a way then the gate has been already a little opened. So it is little by little sneaking in there, but then I guess it will be a long-term process before, and for sure everything will not be then changed. Like in the beginning, the introductory slide, I had this aeroplane with the let's say analog equipment there, and on the other hand, if you think about the current these big planes which are then completely computer based, so changing an old one is probably not going to happen. So it will be a kind of a, let's say, partly something old and partly something new, which will be then in the, as long as the plants are then running there.
Yes, and IoT can also be something that we can equip all the equipment with the sensors and systems to really reassure us that we can keep these systems for maybe 5 more years or something. So I think it's sort of both good for the existing equipment, but also to motivate getting new equipment.
And could be also one, let's say a driver could be that you can get more information. So basically you have the old equipment there. You could even start controlling the old existing equipment with the new add-on technology on top of that. So basically you don't touch the old ones, but you add there something which is measuring both the old measurement system, but can also bring some additional value or additional data from the system that makes then some decisions of the maintaining and maintenance then for the plant then easier.
Thank you. Are there any other questions from the audience? Just raise your hand or write your question in the chat. I think this report is a very good summary, and it's something that you can put in the hands of somebody who wants to sort of know what is the industrial Internet of Things and how can we apply it in the industry.
Thank you. And then it has been really nice to work with you and then to create this report. And then we have been discussing quite a lot during the board about that.
Okay, so if there are no questions, what do you think, Arto? Should we proceed with the next presentation? You want to introduce Paul?
I guess we could take then Paul Smith from the AIT from Austria. So welcome, Paul. We are very happy to have you on board here. So like already pre-introduced, that you will be then digging more deeply to the security issues. So the more microphone and the floor is yours. Welcome.
Thank you very much. Before I start, can you just check you can hear and see me, I guess?
Yes.
Okay. Yeah, good. Thank you very much for the kind invitation to speak today on this topic. So I'm Paul Smith. I'm a senior scientist at AIT, the Austrian Institute of Technology. We're based in Vienna. And this is some work that I've been doing with a colleague of mine called David Allison, who's doing a PhD on cybersecurity for digital twins. David and I, so our background is cyber physical systems security research, and we've been doing that sort of research for the energy sector for a while. And for a few years now, we've been supporting the International Atomic Energy Agency, the IAEA, with some of their computer security initiatives. including research and training and so on. So that's a little bit of our background, where we're coming from. But I'm a computer scientist by trade, as you probably find out. Just in case you don't know who the AIT is or what the AIT is, basically it's Austria's largest applied research center, as I said, based in Vienna, very similar in sort of composition, if you like, or purpose to the Fraunhofer Institutes in Germany. Basically, we're doing various aspects of critical infrastructure research, and me personally and David, we're from this Department of Digital Safety and Security, where we have a team on dependable systems engineering, and I'm part of a cybersecurity group. So that's enough about AIT. Just as context, so when I'm saying things, you understand what sort of position I'm coming from. So the talk outline, I just want to sort of briefly touch on what is a digital twin, including some common applications. I think probably almost everybody on the call here has heard about a digital twin and what it's used for, but maybe it doesn't do any harm just to have some basis, I guess. Then maybe building a bit on a comment from Arto in his previous talk, just a word on computer security of digital twins. And then I think the majority of the presentation, what I'd like to do is talk a bit about some of the applications of digital twins to computer security activities. So the idea is that for the most part, I think the sort of community, if you like, is thinking about the application of digital twins to non-computer security applications. And we've been exploring, well, what could these sort of significant investments in the form of a digital twin, could they have sort of uses for computer security or cybersecurity? Okay, well, what is a digital twin? So I think it's fair to say there's not really a standardized definition of one yet. And I've given this presentation or a version of this presentation before, and usually at some point afterwards, somebody asks me what I think it is and the preciseness of the definition of digital twin. I'm not too sort of, say, religious about it, but generally speaking, I would say a digital twin is some virtual representation, a model or of some sort of a real world system, yeah, a physical, or some part of a nuclear power plant or whatever, or even computer networks. So the IETF are thinking about, Internet Engineering Task Force are thinking about digital twins. But it's some real world system that uses real data for doing analysis and improvement. So there's this idea, there's data coming from this real world system that's being sort of used by this model to answer certain questions. And we'll maybe look at some of those questions in a moment. And I guess one of the interesting things about digital twin is there's a sort of a loop back into the way that the system behaves. So there's some modification to the real world system based on what the digital twin is doing. So what are some of the common applications of digital twins? So I guess, like I say, maybe many of you know some of these already. So obviously it's been used for things like predictive maintenance. So if you can model a turbine or something like this, you can predict when it might need to be repaired before some sort of catastrophic failure. Used a lot in the product design phase. So if you're, for example, designing a controller behavior, like for a programming logic controller or something like this, you might design that against a digital twin of an actual system, yeah, which should make the sort of integration or the deployment of that controller in the field a lot easier. State estimation, so predicting how things are going forward. I think that's a little bit related to predictive maintenance and improving process efficiency. So there are some very nice applications and very good business-oriented applications of digital twins. And as I said earlier, what we're interested in doing or thinking about is if enterprises are thinking about the application of digital twins for these different use cases, could we also leverage these for or use these for computer security applications? So I guess my talk sort of has two sides to it. There's two sides to the coin. There's application, using digital twins for security, and then there's the security of the twins themselves. And I think there's quite a lot of people in the community rightly looking at, well, what additional risks do these introduce? And I think this is important, obviously, for the nuclear sector. So this is an obvious concern, and so I guess one interesting one is that there's obviously a potential for the theft of intellectual property. So the model and the data associated with the model, represents some sort of intellectual property of some sort. And I guess in the nuclear domain, it also embodies potentially sensitive nuclear information that you don't want to have adversaries get their hands on and subsequently weaponize. So ensuring the sort of confidentiality of that information is quite important. That's embodied in the digital twin. And then based on my sort of description earlier of what a digital twin is, in other words, it's sort of, you have the real infrastructure, you take measurements, you compute something using this model to answer questions, and then you have a feedback loop. You could think about it as a sort of distributed or highly distributed control loop, a very slow control loop, nevertheless, but a control loop nonetheless. And then if you think about it in those terms, there are like a collection of attacks that relate to control systems that sort of apply in this domain. So false data injection attacks, so an adversary manipulating the measurements that are coming off the real system in a way to, taint the model is one way of thinking about it, to change the behavior of the model, so it doesn't reflect the real system. Then in the opposite direction, you could think about control command manipulation. So we want to do some optimization based on our digital twin. Maybe an adversary could get in the way of those sort of optimization commands, if you like, or requests, and cause some problems. And of course, there's the integrity of the model itself and the data that it uses. So these are sort of pretty significant concerns that need to be thought about. And I think there are, in many cases, if you look to slightly left or right of the problem space, some solutions that could be applied. So there's a lot of work on detecting false data injection attacks, for example, using physics-based models and so on. So I think this is interesting and definitely needs to be looked at. But I think there are solutions that we can sort of look at from other domains to help us solve this problem. So then switching gears, if you like, to look at the other side of this coin when it comes to cybersecurity and digital twins. One of the applications, or obvious applications, is related to computer security risk assessment. I don't know if you're familiar, but basically risk in this context is calculated as some likelihood of some threat or attack occurring, which is usually a product of sort of the threat actor, some threat actor analysis and the vulnerabilities in the system multiplied by the impact, the consequence. And in both cases, for the likelihood and the impacts, we might think about digital twins providing useful quantitative insights into these aspects. So one of the big challenges with risk assessment traditionally has always been if you like, the values that we apply to these likelihood and impact parameters of our risk calculation are quite subjective often. So we could use a digital twin to maybe make those estimates less subjective. So on the likelihood side, this is kind of indicating a piece of work that we're doing in a project, a European project called Socrates. And one of the partners in there is at the KTH in Sweden, is modeling infrastructures as an attack defense graph. So basically, you model, in this case, an IT or OT infrastructure as a graph, and sort of populate that with attributes of the target environment, so the vulnerabilities, the security controls like firewalls and so on that you have in place. And you could update that model based on the current state of the system, and maybe even from the current, like alerts from security controls like intrusion detection systems, and use that model to get some sort of idea about the current likelihood that an adversary could compromise a target system. And then on the flip side, you could use the digital twin to understand the consequences of or the impact of a cyber attack. So at AIT, we've done some work at thinking about how applying this system theoretic process analysis technique from Nancy Leveson at MIT to understand the different hazards that could be related to different nuclear operations. And in some cases, it's not always apparent whether a particular hazard scenario could have some sort of negative consequence. So here you could see candidate hazard scenarios being evaluated using a digital twin. Yes, so the other area is a little bit more, so if you like, that's a sort of offline to some extent, maybe increasingly online activity. Then the other sort of area where we could see digital twins being applied is to support incident response. So this is basically the part of computer security or cybersecurity when you have detected some adversarial behavior and you want to respond to that in some way. And there's different areas or different places where digital twins might play a role. So initially in helping to perform some sort of anomaly detection. So that could be anomalous behavior of the ICT environment. If you model the ICT environment in the digital twin, or the operational environment. So for example, the unusual measurement values coming from a pressurizer in a BWR or something like this, which could indicate adversarial behavior. Then, so they're having detected that something is unusual, you could use the twin to support root cause analysis. So what's the reason for these anomalies? Try to identify the problem so that you can more effectively respond to that. And in cybersecurity parlance, you would then sort of start or execute a specific playbook for the different type of root causes or courses of action. And then, use it potentially for state estimation. So ask it what if questions. So if I change my cybersecurity controls, what would the effect be on the operational environment? So you could use it to ask questions about how, if I change my infrastructure. So using this model here from Judea Pearl, you could use potentially the twin to ask these interventional and counterfactual questions, which hopefully should expedite incident response. Okay, so there's a lot of discussion about using machine learning models. I'm just getting the sun in my face. Just 1 second. My apologies. That's bad timing. That's better. Yeah, so there's a lot of interest in using machine learning for cybersecurity applications. So anomaly detection, for example, as I mentioned earlier, or even multi-class classification. So using a machine learning model to determine maybe the nature of an attack so that you could classify different types of attack behavior. The problem in this context, in particular in the nuclear attack context, is that we don't have a lot of data sets that represent abnormal states that we could use to train a model. So this is a good thing because we don't want our systems to be breaking all the time. So we don't have a lot of data sets that relate to the failure modes associated with a cyber attack. So the idea is that you could use a digital twin along with some sort of hazard analysis that I talked about earlier to generate data sets that could be used to train these models for machine learning that we could use for cybersecurity purposes or even fault identification. So the idea is we would somehow specify our abnormal behavior, maybe using something like STPA before, execute these scenarios using a digital twin, train our machine learning model, and then deploy them. This is sort of a very simplistic view, of course, but there are sort of some challenges here that we could look to other areas of research to support. So, for example, one of the challenges is that the digital twin, of course, is not entirely representative of the target environment. So it's an abstraction of some sort of the real environment, and therefore any model that you train using data from a digital twin will not necessarily be very 100% representative of the target environment. But there's this concept of transfer learning where you sort of adapt the model parameters using data from the real infrastructure to improve its performance in its deployed state that we could apply in this context. And then, as I mentioned earlier, there's maybe for some of these rare states or these rare conditions, these anomalies that we want to detect, there's perhaps not an abundance of data to train models. So there we could think about using techniques such as few-shot learning, that basically you train a meta model to discriminate between instances of something, and then use so-called few shots. The few shots are our data sets that we don't have a lot of, our anomalous data sets, and use the meta model to say whether it thinks it's closest to one of our few shots or not. So there's a sort of potential application here of digital twins to train models for these types of anomalous behavior detection and classification, and a set of related machine learning techniques such as transfer learning and few-shot learning that could support that process, if you like. So the other obvious, perhaps obvious or not obvious, application of digital twins is for computer security training and exercises. So in the digital twin, you have some sort of representation of your plant, for example, and you could use that to do computer security incident response training. And this is kind of what we did with a one-day exercise that we performed in Korea to support an international training course that the IEA held there in 2019. This, as I said, this is a 2-week course, and one of the capstone exercises in the course was a incident response exercise. And in a related project, we'd created a model of a MATLAB Simulink model of a pressurized water reactor called a shearer. And we used a shearer in this exercise to increase the realism, if you like, of the incident, and illustrate to the participants that the sort of facility level consequences of cyber attacks. So what you can see in these pictures on the bottom right here is a physical mock-up of a condenser system, which includes a programmable logic controller, a human machine interface, and that's talking to, if you like, a digital twin of a pressurized water reactor that's running on a tower PC.
Hi.
Hi, lovely. Can you give us a second? So the daughter's at home sick. Where was I? Oh yeah, model on the desktop PC. And the idea is we could run cyber attacks against this condenser system, this PLC in particular. And though the consequences of those cyber attacks could be understood and, if you like, analyzed using the model that's running on the shearer model that's running on this machine, and then reflected in a mock-up of the main control room. So we could see if somebody attacked the programmable logic controller associated with a condenser, this would lead to some sort of trip at the facility. So if you had a digital twin of your environment, then you could definitely use it for these types of exercises. I guess the interesting thing is that the model needs to be able to calculate these unusual states that cyber attacks can induce. Okay, so just to conclude then, so digital twins, I think it's fair to say in the nuclear sector, so yesterday, so for example, I think digital twins are being thought about in the context of small modular reactors and this kind of stuff. But they're basically, people are looking at digital twins primarily for performance reasons and so on. But there could be a bunch of computer security applications of them that add value beyond that. So in many cases, these applications relate to decision support, so secure design, risk assessment, as I mentioned, and management, incident response and training. And I guess the idea is they can provide sort of more quantitative and realistic insights, of a target environment. I guess what's interesting as well for computer security, you're doing things that you wouldn't want to do on a real system. So it gives you that flexibility there. And I think the idea, or one of the thoughts that with respect to the relationship between machine learning and digital twin is, I think there's, if you look left or right, there's sort of, as part of this industrial IoT ecosystem that we're thinking about, there are potential uses of digital twins for different areas like machine learning, for example, and so on. So that concludes my talk. If you have any questions, I'd be happy to field them. Thank you.
Thank you very much, Paul, for widening our perspective when it comes to what we can use digital twins for. So everybody is most welcome to bring questions to Paul. And I had a question that's not really related to digital twins, but rather like cybersecurity in general. If you compare the nuclear industry to other industries, are we too cautious or are we not cautious enough? Or what's your view?
So, well, so I think you. So I think you're cautious enough. Yeah. So I think so. As I said at the beginning of the talk, we get involved a lot with supporting the IEA on their computer security activities and their guidance. And I would say that and this is a very political answer, but I would say what they're producing there is entirely fit for purpose in this context. Yeah. In terms of implementation, I guess it varies across different states. But I would say that you're cautious enough. I think there's some interesting future directions if we talk about sort of remote operation for small modular reactors and things like this. There's sort of in that sense, the industry is becoming less cautious in terms of what or conservative, let's say, in terms of what they're thinking about. But I think we're thinking about these problems now. So by the time this becomes a reality, we should have some good solutions. And I think it's also important, just to say, I think it's also, a lot of it is about, safety first. So, yeah.
And I think with the sort of new reactors that are coming, cybersecurity is part of the sort of context from the beginning.
Yes.
Well, perhaps for the existing plants that were designed in maybe the 60s, maybe cybersecurity wasn't the #1 issue that was discussed.
No, right. And
done afterwards.
Yeah, exactly. So I guess these plants are going through a process in many cases of digitalization of parts, and I think as they're doing that, I think there are regulatory requirements about computer security in that process that need to be addressed. But yeah, it's an evolving picture, and I would say overall for an industry, I would say it's pretty mature. Yeah.
We have a question from Thomas Smed.
Hello, Thomas Smed. I'm a company specialist on plant dynamics in Forsmark, and thank you for a nice presentation. It made me a little bit less confused on an issue that I've been struggling with for a long time. I'm still confused, I can tell you. I worked with mathematical modeling for 35 years. And as you made your presentation, I Googled the line, what's the difference between a digital twin and a model? And apparently other people are also confused because I got 136 million responses to that. So I didn't have time to go through all of them. But your presentation actually gave me a little bit of a clue to that. And that is that you have, I don't know if it has to be an automatic feedback to the physical reality, or if it's still considered to be a digital twin if it passes a human being.
Yeah, so in the academic literature, I think there's a very nice paper, and I could share that afterwards, by an academic, and he tried to develop a taxonomy, if you like, of digital twins. And I think the idea is that if there's no feedback loop, if you like, into the real system, he calls it a digital shadow. Yeah. So okay. Just to confuse things even further, but whether the human is in the loop or not, or on the loop or whatever, I'm not sure whether that's, yeah. As I said, I think for me, the essential essence of a digital twin is there's data coming from the real system, which is being used to update the model in some sense, or its parameters or whatever. And there is a feedback loop into the real system, whether the human is in the loop there or not. I think depends on the application probably, and the risk associated with that. That would be my assumption.
So are you familiar with what our core supervision looks like?
I can't say I am, no.
Okay, so I'm struggling to understand if that's a digital twin or not, but it probably leads too far that I first explain how it works and then we discuss that.
I think this is a discussion for the discussion session, Thomas.
That's a good one. Yeah. So just to say, my friends in the energy department that we have here at AIT are rather scathing about the word of the concept of digital twins. We've been doing this for many years, they say, and this is nothing new. So I think it's part marketing about, it's the right time, the technology maturity and this kind of stuff it's a bit like the cloud. I always
it's easier to get funding if you talk about digital twins than a model. Absolutely.
Well, that's why I'm a researcher, so that's why I talk about it. I'm always looking for money, so. Yes.
Thank you. Well, I like your description of it anyway. It gave me more information that I have found before, at least.
Thank you. That's kind.
Thank you, Thomas. And Arto has a question.
Or in fact, I was thinking to say a comment for the previous discussion that in a way in the ICT field, okay, like in many others, there is often that then there is the old concept, I guess, especially for the researchers, that there is then this concept where that was then marketed in the, let's say, 20 years ago, but then you don't get any money for that part. So you have to invent the terms to get a bit more and more new. So basically there is the same base behind there, but it's a new name for it. And then you get again funding for that one. So sometimes it could be the model, the digital twin. There is the thing also like in the construction area that if it's the BIM models, then for the let's say the buildings, that there is then either the BIM model just for the planning purposes, or then there is a connected in a way. Then you are moving to the digital twin direction. If you get the IoT connectivity there, that it's then also living at the same time. So it's not anymore that it's the copy of the 3D copy of the plans, but then in a way it's something that can then simulate and see how the things are going there. And as the technology is developing, then the let's say those which were earlier as a nice concept, they can be also implemented nowadays with the current technologies.
Yeah, I think it's exactly. I think it's an evolution of previous technologies in a way.
Yeah.
Arto is also a researcher and
yes.
Are there any other questions? Yeah, I had a sort of a general question as well. I mean, how has the pandemic influenced the development of cybersecurity? Are we taking more risks with working from home office, or have we sort of improved our abilities to defend ourselves, or what's the latest news?
That's a good question. So, I mean, so I'm a little bit distant from that in a way, being from a research institute. But I would say, if I talk to my colleagues in industry, there's a sense that there was an uptick in different forms of adversarial behavior, as a consequence of the pandemic. Social engineering related, for example, to the pandemic became more prevalent. I think a lot of companies pivoted quite nicely to the pandemic about working from home, and I think the security industry as a whole worked quite well. This is my daughter Violet, by the way, who has a cough, as you can probably hear. So I think in general, there's been a slight change in adversarial behavior to take advantage of the opportunity. Just 1 second, lovely. You want to take advantage of the pandemic, but I would say that most organizations have pivoted rather nicely to respond to that.
I think at least from the Energiforsk perspective, it's been a fantastic development, because before the pandemic, we tried to have video meetings, but all the time it was like one organization said, we can only use this one system. And then the other organization in the meeting says, no, we cannot use that system. That is not safe. We can only use this system.
Mm-hmm.
It's sort of all different organizations can use different systems. And then you weeks into the pandemic and the closing down of the sort of workplaces, suddenly everybody can use Teams.
Mm-hmm. I think maybe one of the other sort of issues, perhaps, maybe that's also related specifically to nuclear and access to site, right, is personnel. Like if you need personnel on site, you need to think about that, like cybersecurity personnel on site that can make it difficult to have your teams, together as you maybe did before. So there's potential personnel issues maybe in the longer term, but yeah.
Okay, so it's now 20 minutes to 2, and the main session is now going into break until 5 minutes to 2, and we are starting up in the discussion channel instead. So those of you who would like to continue discussing with Paul and Arto and other participants, you just join the discussion session. The link is in the chat. Or if you rather want to break, you are most welcome to break. We will meet here again in 14 minutes.
Thank you. So let's see you as many as you want, but you can take also the technical break before you join there. So
that is absolutely okay.
Yeah. So see you soon in the next event there.
Thank you. I'll see you there.
I guess one of the challenges for the webinar type of, it's nice that people are easily can move and go, but then there is not this ringing bell or something that is calling the people from the cafeteria for the corridors inside. So in a way, we have to just rely that then the people remember to come back in time.
Yes, I do miss my bike horn that I usually have.
Yeah. Okay, you could use it, but unfortunately that wouldn't be heard by the others.
My son's clock, radio control. So it's
That's
actually time to start. And now we will hear more about the activities at the Nordic plants. We are starting at the west coast of Sweden with Andreas Björklund. Andreas is also part of the steering group for the Energiforsk digitalization in nuclear program. Welcome, Andreas.
welcome also
Thank
on
you.
my behalf.
Thank you. You can hear me?
Yes.
Perfect. So then I should share my slide then. Let's see. There. Can you see this?
Yes.
Perfect. Yes, my name is Andreas Björklund and I work at Ringhals nuclear power plant. Daily I'm the manager of plant strategy and our investment portfolio. But I also work a lot with the area around digitalization. So I'm going to tell you a little bit about where we stand today and what we work with within wireless and IIoT. Yes. First, Ringhals, as you said, Monica, is based on the west coast in Sweden. And we today have 2 reactors operating, PWRs, and within, or I should say that Vattenfall is our main owner, and within Vattenfall, our nuclear generation, then we also have Forsmark, that is based east of Sweden, a little bit up from Stockholm. That probably some of you know where that is. And Forsmark have 3 reactors, 3 BWRs. I will mainly focus on Ringhals today, but in some areas also, of course, Forsmark is with us. I will start with the foundation then, our asset management. This is, of course, our big focus area, and we want to strengthen our asset management. And then we see that we have digitalization as a part of strengthen our asset management. So yes, digitalization overall, but also this part with wireless and industrial Internet of Things is of course a part of our asset management. We talk about monitoring, diagnostic and prognostic, and that is in particular a part of our performance monitoring based on one of performance objectives and criteria that we see as a good practice. So we see that we should use the data and information, for example, then within our scram reduction programs and our reliability centered maintenance. The focus area are system and component, such as single point of vulnerability and or criticality. We see that the main target group here is our system engineering and our maintenance. Also our operation and analytic competence skills are also a part of this, of course. But it is a network then with people. So the beginning, we started to talk about a digital ecosystem. We have our plants and assets, and also assets within our employees, our operational personnel, and our way of working. But as I said before, then we looked into this area around monitoring, diagnostic, and prognostic. And then we started to see what kind of IIoT equipment should we need in the future. Then we can see that we focus on cameras, sensors, drones, smart meters, for example, pressure, temperature, flow, vibration, electricity, chemistry, positioning, etc. We do have a lot of data today, but we need more. So it's a cost efficiency to bring and gather data through a wireless technology. So that is a piece that we need then. Also to actually bring up this data and work with it within our way of working then. So through tablets and glasses, etc., then we can use it for real-time and history information, documentation, work orders, error reporting, barcodes, back office support, and etc. And then to integrate and work with this data within this digital ecosystem, then we need to have a safe and reliable integration platform, a data center. And here we talk about storage, security, of course, scalability, and trust, also performance. Then we also can aim for those specific parts then around monitoring, diagnostic, and prognostics, and a more detailed for our system engineering network, but also for our overall management and leading and lagging indicators for our KPIs, such as plant performance, safety and risks, staff performance, safety, efficiency, also cost monitoring. Oh, sorry. Yes, here it is. Yes. So mapping the prerequisites then to achieve a digital ecosystem. Of course, as always, we aim for a IT safety and security. So plant network and administratively network, including categorization of sensitive data. That is, of course, very, very important. Related to the IT infrastructure, then wired and wireless, safe, secure, and available with full coverage within our plants. IT architecture, then storage and servers, including a good data management through data warehousing and cataloging of our data. Standard and regulations, overall alignment to maintain our construction bases. And last but not least, then work with our partners and stakeholders, close to our partners and stakeholders. Experience coverage and good practices, that is very important for us. We know that we are not first here, so it's good for us to actually get this kind of experience coverage from others that is way a bit longer than us in this digital transformation. So the missing piece, wireless and IIoT platform then. We have an ongoing project of installing wireless at Ringhals, and it should cover our plant facilities. We're building it with a backbone that is based on copper and opto fiber, and the selected technology is now Wi-Fi, with some future compatibility also for other standards. And this is classified for industry. For us, this is a private and on-premise network, and it includes a zone model to ensure data access and data security. And the purpose of the wireless network is only for informative data. That is very important, not for controlling. Start installation next year. And there will be a successive implementation facility by facility. Challenges, as always, cybersecurity. You have already mentioned it before, and I believe that we will hear more about it today. But it's also a lot about separation and shielding to avoid disturbance of existing equipment. We have a short equipment life cycle, probably around 7 to 10 years. There will be some new extensive preventive maintenance of batteries then, which is related to our IIoT equipment. There will be extensive cabling to achieve a good and robust backbone. Also to achieve a technical standardization and rules for IoT equipment. That is not okay to connect everything. We had to have some rules here. Constantly new upcoming technologies and protocols. For example, now we talk about a lot about 5G. So a little bit more than what we aim for, and that is the past, the present, and the future monitoring, diagnostic, and prognostic center. We are in a phase here now with a small startup of implementation of a MDP center, and that should cover a user interface with dashboards and indicators for system and component health assessment, including alarms and notifications. So it should be accessible and easy to use. Leading indicators for equipment reliability, and to take the next step and achieve more prognostics and prediction, then it's more about applied analytics for pattern recognition and predictive maintenance and system health. So it's governing a condition-based maintenance also, of course. So the purpose and value then, you have probably talked a little bit about it before here, Arto, but for us it's a lot about reduced maintenance cost and better component and system availability and reliability. Early indicators of possible potential and fault for avoid failures and breakdowns. Corrective maintenance and unnecessary change of components. Reduce the amount of manual plant inspections in some areas. Optimize our maintenance in specific areas by steering towards needs rather than periodic service intervals. And through predictive maintenance, focus and steer for the best suited location to maintain components, for example, due to operational state. And we also can work with the lifetime extension of components and system through stronger real-time monitoring of leading health indicators. So that is what we aim for. And the prerequisites here is to actually define objects due to single point of vulnerability and or criticality. And then from that, define target areas, depending on if it's a pump or a valve or something like that. And there are probably some standards and best practices for this. What should we actually measure to get a good bigger picture of the state and the health of the specific object. We should define data then and information sources and gather relevant input. And then define a digital integration platform. And there is probably a lot of data models and algorithms that we can use, but that is an area that we have to look into more and also how we should visualize this and make a good user experience. So that's why we always have to define, gather, and cooperate close with interests, both internal and external. Challenges: data and information management and governance. Sometimes in this kind of areas, then it's a little bit more about understanding and also confidence. In some areas, lack of competence skills then related to this new ways of working with the IIoT and also then data science and user experience. Find the best suitable data models for the specific object to fulfill the purpose. And inclusion and then of predictive and condition-based maintenance in today's working methods and processes. And then priority and business case, the workload and the effort. That's my presentation from Ringhals. Questions, anyone?
Thank you very much, Andreas. Any questions to Andreas? While you're thinking of questions, let me ask you, I mean, we discussed earlier about these business cases that you need to show a business case to do something in the plants, but I mean, installing wireless, that's sort of a facilitator for a number of other business cases. So what was the reaction from the management when you suggested that we have to have an installation of wireless at Ringhals?
It's probably the same always with the infrastructure. Then it's not so much money or cash back within the specific infrastructure. For this example, then wireless. So we have to look into how we actually should use it in the end. So that's why I aim a little bit here within this presentation on what we want to achieve, and this is and specific areas then monitoring, diagnostic, and prognostic, but also mobile workers, of course, and how we can use it in our ways of working and so on. So there is many areas that we can achieve, but that's something that we have to work with within our organization and build new business cases around. So.
I mean, you do want it to be like something that becomes like a snowball. You get it into motion, and then it just grows bigger and bigger. You find new applications and new use cases, new business cases.
Yeah, of course, that's what we hope for, and we try to talk to within our organization around this as much as possible. And also try to address this within our needs when it's time for new projects within our plants. Then it's time to actually bring that question up. Then how to use the wireless.
Arto, you had a question.
Yeah, first of all, thank you for the nice presentation. And then I guess that is the very important thing, that you have sneaked the wireless into the plant now with this construction, because in a way now you have the tools then that you can then, it's easier for the next steps to start then adopting, because you don't have to say that, well, we would like to have this, but because we don't have the wireless connectivity here, we can't do it. So one step is taken already to proceed there. I was just thinking to ask then, have you been thinking, because now you are in the process already there, that are you going to then gain a lot, or in a way acquire a lot of this in-house IoT skills there before you go further, or is it so that it will continue growing there during the process when you are then enhancing the systems there?
Yeah, for the moment it's more of the last part there. Then we aim for a growth within our organization and our business here, so that we can see the possibilities. And in the meantime, we try to actually inform about this in separate forums, and try to create an interest and an understanding as well.